Section 6.2, Rational Numbers as Exponents. Consider x to the 1/2 power times x to the 1/2 power. What does x to the 1/2 power mean? A fractional exponent. That's a curiosity. But we have rules of exponents, and we know that if you multiply x to an exponent times x to another exponent, the rule is you add those exponents. So we're going to add 1/2 and 1/2. And what is 1/2 and 1/2? It's 1. So it's like x to the first power, but you don't have to write the 1 because it's understood to be a 1. So when we multiply, we add the exponents, whether they're fractions or not. Then we have x to the 1/2 squared. What do you do with exponents when one is inside a parenthesis and one is outside a parenthesis? You multiply them. So we have x to the 1/2 times 2. And what is 1/2 times 2? It's 1. So once again, we get x as our answer. So let's think about this. X to the 1/2 times x to the 1/2 gives us x. So we're going to multiply something times itself and get x. So what does a 1/2 exponent mean? Or a 1/3 exponent, or any kind of fractional exponent? If n is a natural number, n is not equal to 1, then a is a non-negative real number, so it can be 0 or it can be positive. Then a to the 1/n means the nth root of a. The nth root of a. So when you have a fractional exponent, it means a root. So when we had x to the 1/2 times x to the 1/2, that really meant the square root of x times the square root of x. And so of course when we multiplied those together, we got x, assuming that x is non-negative. And when we had x to the 1/2 squared, that's like the square root of x squared. So when we did that, of course, we got x. So fractional exponents mean roots. Whenever we use rational exponents, we will assume that the bases are non-negative. Because if those bases are negative, that gets us into a whole problem we don't want to talk about. So let's rewrite these problems without rational exponents and simplify if possible. So when it says 49 to the 1/2, what does that mean? 1/2 means square root. So it really means the square root of 49. Do you know what the square root of 49 is? 7. And once again, we're taking the principal square root, the positive square root. When you say 27 to the 1/3 power, you really mean the cubed root of 27. So we're looking for a number that you write it down 3 times and multiply, and you get 27, and that number has to be 3. So when you say xy to the 1/4, it's both x and y to the 1/4. You mean the 4th root of x times y. Let's rewrite with rational exponents. This time we're given the radical. We're going to rewrite it with fractional exponents. So this is the 7th root of 4ab. That quantity, 4ab, we need to put it in parentheses to show that we're talking about all of that. And we're raising it to the 1/7 power. 5 times the cube root of xy. Can you do this one? You may want to pause the video for a minute and work on it. We have 5, and what's being raised to the 1/3 power? Just the x and the y. So we use our parentheses to show what was under the radical. Here we have xy over 6 is under the radical. And what fractional exponent do we want to raise it to? 1/5. So if m and n are natural numbers, n is not equal to 1 and a is a non-negative real number, then a to the m over n. We have fractional exponents here. The denominator n indicates a root. The numerator m indicates a power that you're raising it to. What this is saying here is that it doesn't matter whether you take the nth root of a to the m or you take the nth root of a and then raise it to the mth power. So it doesn't matter whether you take the root first or raise it to the power first. It is usually easier to take the root first so that you're dealing with smaller numbers. Rewrite without rational exponents and simplify if possible. So we have 16 to the 3/2. Now remember, we said we could take the root first or raise to the power first. So we could think of this as the square root of 16 and then raise it to the 3rd power. Or we could think of it as 16 to the 3rd power and then take the square root. Well, 16 to the 3rd power is a very large number. I don't want to go there. But the square root of 16 is just 4. I like that. And 4 cubed is 4 times 4 times 4, 64. So I am going to take the root first. That's just my preference. I'd rather deal with those smaller numbers. So 81 to the 3/4. We could take the 4th root of 81, and then after we do that, raise it to the 3rd power. What is the 4th root of 81? What number can you write down 4 times and multiply it together and you will get 81? The answer is 3. And then we have to raise that to the 3rd power, 27. Let's rewrite with rational exponents. So here we have the square root of 7 to the 5th. So 7 is our base, 5 is the power that we're raising it to. It goes in the numerator. It's the square root, so we put a 2 in the denominator. Roots are in the denominator. So we have under the radicand is 5x squared y cubed. That's what we're talking about. What are we doing to it? Well, we're doing two things. We're raising it to the 7th power, and we're taking the 4th root of all of that. So that's a good way to write it with fractional exponents. The denominator of a rational exponent is the index of the radical. And the index is this little number right here. It's telling you what kind of root it is. Is it a square root, a cubed root? You need to know. The numerator of a rational exponent indicates the power to raise it to. The power to raise the radicand to. Negative rational exponents. What does a negative exponent mean? For any rational number m over n and any positive real number a, then a to the negative m over n. If it's negative m over n, we can think of that as 1 over a to the m over n. So a negative exponent indicates location. If it's in the numerator, it belongs in the denominator. Once you put it in the denominator, you can then realize it's positive, so the m is the power that you raise it to, the n is the root or the index. So let's rewrite each with positive exponents and simplify if possible. 8 to the negative 1/3. The negative indicates you're in the wrong location, so we're going to change it to 1 over 8 to the 1/3. Negative exponents indicate location. 8 to the positive 1/3, that's a fractional exponent, so we're taking the cube root of 8. What is the cube root of 8? 2. 32 to the negative 4 over 5. Take care of that negative exponent first. We take 32 to the denominator, and it will be a positive 4/5. Now remember, that's the fifth root of 32, and then we will raise that to the 4th power. What is the fifth root of 32? 2. We have to raise that to the 4th power. So write down 4 2's, 2 times 2 times 2 times 2, 16. 7xy, that quantity, raised to the negative 5 6. Negative exponent means we have to take it to the denominator. I'm going to go ahead, and while I'm down there, I'm going to realize that that 6th root, or that 6 in the denominator, means it's the 6th root, and then I can raise that to the 5th power. And really, that's all you can do with that. We don't know what x and y are, so we're through. We have a negative exponent here, so let's think about this for a moment. If you have 2ab, that exponent would apply to it, negative 3/4 over, now wait a minute, I better put that in parentheses, so I show that that quantity is raised to the negative 3/4. And if I have 3c to the negative 3/4, both the numerator and the denominator have been raised to negative exponents. Negative exponents indicate you're in the wrong location. So if you're in the numerator, you belong in the denominator. If you're in the denominator, you belong in the numerator. Both of these are in the wrong location. We need to take that 3c to the numerator, and then it will be positive 3/4. We need to take that 2ab, oops, I forgot to put it in parentheses. We need to take that 2ab to the denominator, and it will be positive 3/4. Now I want you to compare that to the original problem. Look at that. We had 2ab over 3c, and now we have 3c over 2ab. That's why some people think of negative exponents, fractions raised to negative exponents. They think of it as a rule that negative, wait a minute, I wish I could spell. Let me try that again. Negative exponents, you can think of it as negative exponents. They flip fractions. And sure enough, we flipped this fraction. So both of these are raised to the 3/4. So I want the 4th root, and then I want to raise it to the 3rd power. And my fraction is now 3c over 2ab. So a negative exponent flips a fraction. Laws of exponents for any real number a and any rational exponents m and n. The rule is if you are multiplying a to the nth times a to the mth, or backwards, that equals, what do you do with the exponents? You add them. That's a to the m plus n. This example, we have x squared times x cubed, and we get x to the 5th. That's easy to see if you think of it as x squared is x times x. x to the cube, x cubed is x times x times x. You have 2 of them, you have 3 of them, you end up with 5 of them. So of course you add the exponents. Our second rule is if you have a to the m over a to the n, you subtract the exponents. That's a to the m minus n. That's easy to see in this example of x to the 5th over x squared. Think about x to the 5th. You have x times x times x times x over x squared is x times x. Now think about it. You can cancel these guys, cancel these guys. What do you have left? You have 3 in the numerator. So when you're dividing, you subtract exponents. You surely don't want to write out x to the 31st or something like that. So that's why we have these rules, so we know to just subtract. But it's nice to write them out to understand where the rule came from. Look at rule number 3 here. A to the m to the n. If you have an exponent inside and outside of the parentheses, you multiply those exponents together. So x cubed squared equals x to the 6th. That's easy to see because x cubed is x cubed and we want to square it. So we write it down twice. And when you write it down twice and you multiply, you add the exponents, 3 plus 3, you have x to the 6th. So of course, if there is an exponent inside and outside the parentheses, you multiply. If you have a product in the parentheses, so we have a times b raised to the mth power, you want to raise both the a and the b, both factors, to that mth power. So it becomes a to the m times b to the m. An example, xy to the 4th. That's easy to see if you think about what does it mean to raise something to the 4th power. It means write it down 4 times, then multiply, and the order in which you multiply doesn't matter. So you have x to the, how many x's do you have? 4. How many y's do you have? 4. So it's x to the 4th, y to the 4th. So it's nice to know that when you have factors inside of the parentheses raised to an exponent, that exponent applies to both factors, or all 3, or all 4, or all 5 factors inside the parentheses. And our last rule is applying exponents to a fraction. If you have a to the mth over, or a over b to the mth power, you can raise the numerator to the mth power and the denominator to the mth power. So you have xy to the 5th power. We could just logically think about it and say, hey, if you're raising something to the 5th power, you have to write it down 5 times and then multiply. Well, if you write x over y down 5 times and multiply, you get x to the 5th in the numerator and y to the 5th in the denominator. So our rules of exponents, we know very well. We've seen them before. And now we want to use those to simplify. The catch is this time we have fractional exponents. All answers should only contain positive exponents. So we want to make sure we only have positive exponents. So 7 to the 1/5, 7 to the 3/5, what's our rule for exponents here? You want to add them. What is 1/5 plus 3/5? We've got a common denominator. Just add those numerators. 7 to the 4/5. X to the 1/2 divided by x to the 1/4. What's our rule for exponents when you're dividing? You subtract. What is 1/2 minus 1/4? I hope you know that without working through step by step. It's 2/4 minus 1/4. That's x to the 1/4. 5 to the 5/6 raised to the 3/2 power. What do you do with exponents when they're inside and outside of the parentheses? You multiply them. What do you get when you multiply these guys? 3 goes into 6 2 times, so it's x, then you multiply through, so it's x to the 5/4. Here we have a negative exponent. Let's see if that causes a problem. And we have factors inside the parentheses. So we have x to the 1/3, but then we have to raise that to the negative 15th power. We have to multiply. And we have y to the negative 2/5 to the negative 15th power. We have to multiply. What is 1/3 times negative 15? Negative 5. What is negative 2/5 times negative 15? A negative times a negative is a positive, so I know this is positive. 5 goes into 15 3 times, so it's a positive 6. But our final answer can only have positive exponents, so we need to rewrite this with positive exponents. Y to the 6th is positive, leave it alone. X to the negative 5 is negative. That means it's in the wrong location. It's in the numerator. We have to take it down to the denominator. Let's use rational exponents to simplify. So we have 9 to the 4th power, and then we're taking the 8th root of that. So it's 9 to the 4th power and the 8th root. The index always goes in the denominator. What is 4/8? 1/2. And what is 9 raised to the 1/2 power? That's the square root of 9, 3. Take a moment to enjoy how lovely it is to get an answer of 3. The 8th root of 9 to the 4th power is 3. Well, I sure would rather deal with 3 than the 8th root of 9 to the 4th power. That's why we spend so much time talking about rules and simplifying, because you can get some really nice answers where once you had a mess. So we have the 5th root of xy to the 15th power. So xy is what we're dealing with. That's our radicand. We're taking the power of 15, that goes in the numerator. The root of 5 goes in the denominator. What's 15 divided by 5? 3. Now we could leave it like that, or we could write it x cubed, y cubed. Doesn't matter. Either way is fine. We have the 6th root of x, or a to the 12th, b to the 18th. So this is a to the 12th, b to the 18th, to the 1/6 power. What do you do with exponents inside and outside the parentheses? You multiply them. So really that gives you 12/6 and 18/6. What is 12 over 6? 2. What is 18 over 6? 3. Oh, look at this one. This is complicated. We have the square root of the 5th root of x. So take x. What happens to it first? The first thing that happens to it is we take the 5th root of it. And then what do? We take the square root of it. What do you do with exponents inside and outside parentheses? You multiply them. So what is 1/5 times 1/2? 1/10. We can leave it like that, or we can write it as the 10th root of x.